It's dark in here today. So it's rainy. It's a little dark. But also, I wanted it to be dark. I have the light off. I'm just using the light coming in the window and a little lamp over here because we're going to be working with some lights that I want you to be able to see. And you can see a little bit better if it's a little bit darker in here. I'm going to have to do a separate tutorial video on how I made these. I just don't feel like I have the time or any of that in this lesson video on how I made these, but I will probably over the weekend or something make a tutorial video on how I put these together. I'm going to go next into the first bit of the slides that are on circuits, because that bit, again, should be review from the 5th grade. Then we'll come back here and I'll show you a little bit with the lights for series and parallel circuit discussion. And then we'll go back and finish up the slides. So see you behind the screen in just a minute. Here are the slides for today's lesson. So this is all about circuits and currents. So the first little bit is, again, review. It's about closed versus open circuits. So you need to do the drag and drop for your vocabulary. So the first thing is, what is an electric current? So an electric current is created from the continuous flow of electricity. A circuit is the path that this current flows, the path that the current follows. A closed circuit is a complete circuit. An open circuit is a broken path. A closed circuit is when there's an unbroken path. An open circuit is when any parts of the circuit are disconnected. And of course, you paused and did that first, right? Of course you did. Next up, closed or open. So pause and drag and drop where those go on each of the things. Make a guess as to whether it's a closed circuit or an open circuit. All right, you paused it. You're back now. Let's review. The first one is definitely an open circuit. Not only are the light bulbs out, but you can see an opening there. The second one in the middle on the top row is a closed circuit. The light is on and you see no open gaps. In the third one on the top row, that is an open circuit. While there are no gaps in the wire, the switch is open. Down here at the bottom, this metal switch should be down and touching this piece of metal if we want the electricity to flow. Since it's up, it's open. Also, the light bulbs are off, and that gives you a pretty good clue. Now, this one, you don't see any obvious open gaps. However, the battery is not being used. They've drawn it differently for a reason. And then also the light bulbs are off. So I'm assuming one of the light bulbs is bad. And since there's no switch to turn it off and everything is connected, there's obviously still something making it an open circuit. Either they need to put in a new light bulb or they need to check their wires or something. This is a closed circuit. We have complete pathways and the bulbs are lit. And this one is an open circuit because it has an obvious opening in the wire. Next slide. You're supposed to go up here into the tools. I like using, not tools. I like these tools. I like using the scribble so that you can just draw. You're going to start on one end of the battery and draw a line. That didn't work. Let's try again. You're going to start on one end of the bat. Come on now, really? Start on one end. Start on one end of the battery and draw over to... Now, if I was actually wiring this, I would probably wrap it around there a couple of times. But as long as it touches the metal, it's okay. And then back to the other end of the battery. And that would be a closed circuit. Now here, creating an open circuit, assuming I can get the tool to work, you just need to not make it, that's a pretty lazy way to do it here. I'll draw more. But as long as the pieces don't connect, it's an open circuit. All right, now you can imagine that when an electrician is doing his job, he doesn't draw little light bulbs and things like that. So electricians use diagrams, and there are specific symbols that are used. The circle with a X in it means a resistor. Normally, they're planning out lighting, so it would be a light fixture or a light bulb of some kind, but it could be a resistor of any kind. It could also be an outlet. The place here where there's a two dots and then a line connecting it in the closed circuit, and then there's two dots and then the line is slightly open in the open circuit, that's a switch, and that's the symbol that's used to draw the switch. And over here, the short line and long line, that's just showing where the electricity is coming in and going out from the house current. So when you look at this and it tells you what on the diagram tells you if the circuit is closed or open. So this is saying it's a closed circuit. This is saying it's an open circuit. So what's the only difference between these two things? Yeah, that right there. So what on the diagram tells you that the circuit is closed or open? The switch being open on the open circuit shows an incomplete path and open circuit. So the switch is the thing on the diagram that tells you what you need. Next up, we're going to discuss series and parallel circuits. So we reviewed what the difference is between an open circuit and a closed circuit. So now let's talk about the difference between series and parallel. Now, we know that as long as our wires are not connecting and we're not making a complete path, it's an open circuit and our light bulbs won't light. So we've got to make a complete pathway for the electricity to follow. For our light bulb to light, we need a closed circuit. So first we're going to make a series circuit where there is one path. So in a series circuit, there is one pathway for the electricity to flow in. So I have two batteries here. I've made a little battery pack out of 2D batteries. Just wrap them together with a whole lot of electrical tape and use my little connectors like I showed you in the last video. So I'm going to connect one end to one end of the battery. And as soon as I bring the other end near, you'll see we get nice bright light. And that's just one pathway for the current to flow. What if I add another light bulb? Still, it's one pathway. I'm just adding another light bulb to the path. Now, it still lights, but look, they're so dim. Poor, dim little light bulbs. It's because when you add a bulb to a series circuit, it's that same amount of electricity being pushed through the wire and has to be shared. So they get dimmer. If you add enough bulbs and overcome your battery source, eventually they just don't work at all. Well, what if I take one of these light bulbs out? That happens sometimes, right? And it, oops, gets lost. So I'm still going to connect one end and one continual circuit. So my empty bulb gets connected into the other end. And when I bring the other end of the wire toward the battery, that bulb doesn't do anything because that is now an open circuit. Because there's no bulb here, there's no complete pathway. So it's an open circuit. So if one goes out, they all go out. So series circuit, one pathway. If you add a bulb, they get dimmer. If one goes out, they all go out. Now in a parallel circuit, it has more than one pathway. Now because it's wires and not boards, electricians can get a lot more creative with their circuits than the person who built the wall can get. You can do some intricate things with your wiring, but mostly you want each of your items to just have one pathway, something that goes to the switch in series so that the item can be turned on and off, but so that if one item goes out, you don't want the whole rest of your house to go dark. So your house is wired in parallel. And oftentimes different things in the room are wired in parallel so that if you turn your switch off, other things don't happen. Now, sometimes they do. You know, when you turn the light on over here and turn the switch on over here and the lamp over there in the corner turns on because that switch runs that outlet over there, those are wired in series because that's the only way that'll work. But otherwise, normally, just like in my classroom, I had those 3 sets of lights. Each set of lights was wired in series, but then they were wired in parallel together. So if one went out, the others did not. So let's see what happens when we add bulbs, and let's see what happens when one goes out. So again, I still have my little battery pack and my same connectors, but to give everything a separate pathway, I had to get a little creative. So we're testing to see just how good of an electrician Miss Harris is. So I have one wire that's going to come from the battery, and it's going to my one alligator clip that I did have. And then I have 3 of those connectors stacked on top of each other and clipped into that alligator clip. Then 3 of the lights, and then each of those 3 wires comes into the other end of this electrical connector. It's from a electricity kit that I had in my classroom. These are pretty cheap and pretty easy to find. And on the other end of the piece of wire that those are connected to, they're wired into this, I have used a piece of electrical tape onto that piece of metal, and then that goes to the other end of this connector, which will go to the other end of the battery. So what that means is the electricity comes in here and then has 3 different pathways before it goes back out again. So it is wired in series. So let's see what happens. I mean, wired in parallel. Oh, at least I caught it this time. Look at that. 3 bulbs on those same 2 batteries, 3 bulbs, and they're just as bright. Remember what happened when I put just 2 bulbs in series? It was so dim you could hardly see it. But because I've wired these in parallel, I've got 3 bulbs and they're nice and bright. Now, what happens if I remove a bulb? Oh, I forgot to put my notes here. So if I add bulbs, they stay bright. So what happens if I remove a bulb? Right? They fall out all the time. So there it is, empty one. Let's see what happens. The other 2 are still shining bright, and the empty one's just sitting there empty, like it's no big deal. So that's the other great thing about being in parallel. Rest, stay on. So just because one goes out, the others can stay on when it's been wired in parallel. Okay, see you to finish up those slides. So now we need to finish the slides on series and parallel circuits now that we've talked a little bit about those. So the next slide is about the vocabulary of series versus parallel. So now that we've chatted about it, pause, answer your own. Okay, so in a series circuit, there is one pathway for the current, and a break will stop the current and the lights will not stay on. A parallel circuit is more than one pathway for the current, and a break will not stop. Now, of course, if you do a break within that one pathway, the current's going to not flow in that pathway anymore. But if you break one pathway, the other pathways will stay lit. All right, next slide, slide 10. Is it series or is it parallel? So pause, drag and drop on your own. Right, the first one is series. There's just one pathway for all of those. The next one is parallel because they're stacked on top of each other. There's a single pathway for the top bulb and then another pathway for the bottom bulb. The third one on the top is a series, just one pathway. Bottom left is also series with just one pathway. Bottom middle, that's parallel. Each of those lights have their own pathway. And the bottom right is also parallel. Each of those have their own pathway. Slide 10, you're going to use your scribble again to draw a line and create a series circuit. So for it to be series, it needs to be just one line. So from one end of the battery to the bulb, to the next bulb, and then back to the battery. Slide 12, you're making a parallel circuit. So again, grab your scribble tool. You're going to start on one end of the bulb or the battery and go to the first bulb and then back again to the battery. And then again, take your scribble tool and draw another line from the battery to the bulb and back to the battery. Now, there are multiple ways to do this, as you saw in my demonstration. Electricians can get pretty creative as long as there are separate pathways that the bulbs are on. Next up's a drag and drop on series circuits, so pause and drag and drop on your own. It is a series circuit if there is only one pathway for the electrical current to follow. It's a closed circuit if all the bulbs light. It's an open circuit if the bulb is unscrewed or if there's a break in the path. Parallel circuits, drag and drop. Pause and do your own. All right, it's parallel if there is more than one possible path. If one bulb is removed or fails, then the others stay as bright as if each one was the only bulb. And in parallel circuits, the bulbs stay as bright as if each one was the only bulb. To left, slide 15 is a compare and contrast for series versus parallel. And we're going to go back to the board for just a minute before we finish this. So for the Venn diagram, this information is going to be very helpful to you. So this is what you need for the series side of your Venn, and this is what you need for the parallel side of your Venn. So pause and get that information into your Venn diagram. So one pathway, you add a bulb, it gets dimmer. One goes out, they all go out for series. And then parallel is more than one pathway. Add bulbs and they stay bright. If one goes out, the rest stay on. So the Venn diagram here, what are the three things that we need on the series circuit side? That's right, one pathway. If we add bulbs, they get dimmer. If one goes out, they all go out. Parallel, more than one pathway. Add bulbs, stay bright. One goes out, stay on. Now, what things do they have in common? Well, they need a closed circuit to work. It's a flow of electricity, which is electrons in one direction and made up of conductors. Here. All right, last one. A shopping mall is putting up lights for the holidays. When they plug the holiday lights in, the lights do not light up, and we can look at it and tell what kind of circuit it is. There is only one pathway that electricity is following. So what kind of circuit have they got? They have a series circuit. So what can the employees do? Well, it could be that they only have one bulb out. Most likely there's more than one on each row. So they are going to just have to test each bulb and replace them until they are all. And that's it. Well, we've come to an end of another lesson on electricity, this one on series and parallel circuits. Thank you once again for joining me. Hopefully you got to review good information, learned a little something new maybe. Like I said, I'm going to release a how-to video on how I made all of these things probably sometime over the weekend. Y'all take care, be good to each other, make good decisions. Bye.